Hi friends, in this video we will discuss about the consistent hashing. Okay, how we made the consistent hashing and where it is useful. Okay, let's discuss about consistent hashing in detail. Consistent hashing. Okay, the consistent hashing, generally we use it to distribute the data across the nodes. Okay, let's see why we need to use the consistent hashing to distribute the data across the nodes before discuss about the consistent hashing. Why we need to use consistent hashing. Okay, why we need to use a consistent hashing? For example, we have three nodes. Okay, we have three nodes. First one is node 0, node 1, node 2. Okay, node 0, node 1 and node 2. Node 1 and node 2. Okay, we have three nodes. If we need to distribute the messages across these three nodes, generally what we need to do, we have message ID and original message. We have message ID and original message. Generally what we need to do, we need to hash. Okay, hash the message ID, and modulus of total number of nodes. Okay, for example, we have the messages like this: message ID 1, message ID of 2, message ID of 3, 4, 5, 6, 7, 8 and 9. Okay, for example, what we need to do, hash the message ID. This, for example, if you hash this complete message ID to the hash function, for example, the hash gives an 1 value. Okay, we need to pass through the hash function message ID. It gives the value 1, for example. Okay, 1 modulus total number of nodes is 3, then what it give? 1. Okay, if you similarly perform this message id 2 into the hash function. For example, it gives a 2 as a value, the value as 2. Okay, for example of id of 3, if you perform this message id to the hash function, it gives an value 3, modulus of 3, that is 0. Okay, similarly for message id for 4, modulus of 3, it gives an value 1. Similarly for fifth message id 5, modulus of 3, it gives an value 2. Similarly for sixth message id, sixth modulus of 3, it gives an 0. Similarly for 7 modulus of 3, it gives an value 1. For 8 modulus of 3, it gives an value 2. For 9 modulus of 3, it gives an value 0. Okay, now what happened, the messages will distribute into the all the 3 nodes, right? This third message id 3 and message id 6, okay, and message id 9 will goes to node 0, at the same time message id 2, okay, message id 2 and message id 5 and message id 8 will goes to node 2. Okay, in the similar way message id 1 and message id 4 and message id 7 will goes to the node 1. Okay, so distribution of message was successfully completed between the nodes, even there is no consistent hashing. But there is a big drawback in this. Okay, let's see what is a drawback in this approach. Drawback. Okay, we have 3 nodes, right? Node 0, node 1 and node 2. Okay, so for 0, what are the messages we distributed? Message 3, okay, message 6 and message 9. For node 1, message 1, message 4 and message 7. Message 1, message 4 and message 7. In the similar way for node 2, message 2, message 5 and message 8. Okay, this is the distribution of the nodes, messages distribution. For node 0, for node 1, for node 2. Okay, let's imagine this node 2 is down. Okay, node 2 is completely down. Okay, now what happened, we transferred these messages to the either for the node 0 or node 1. Okay, for example, these messages were transferred to the node 1. Node 1, message 2, message 5 and message 8, because node 2 is down. For example, if you need to retrieve the message 2, okay, I need to retrieve the message 2. What happened here? I need to retrieve the message 2. I perform the hash function. Okay, its value is 2. Okay, 2 modulus of total number of nodes is 3, it gives an value 2. Okay, but this message, this node 2 is down. So in this approach, distribution of messages was successfully completed, but retrieving of messages was not yet done if any of the node is down or if any of the node is added. Okay, so adding of the nodes while removing of the nodes, it becomes a problem for this approach. So to solve this approach, to solve this issue, we have consistent hashing. We have consistent hashing. Let's see what is meant by the consistent hashing. Consistent hashing. Okay, consistent hashing consists of hash function. Okay, consists of an hash function, but what kind of hash function it has? It consists of lower limit and it consists of upper limit. Okay, that means what are the messages we are sending through this hash function. Okay, it gives an output, right? This output, whether is always output is always between in the lower limit or upper limit. Okay, it did not cross the lower limit and it did not cross the upper limit. Always the output value lies between the lower limit or upper limit. Okay, that kind of hash function the consistent hashing technique should have. Okay, now let's discuss about the technique. For example, we have hash function which generates value between 0 to 1000. Okay, 0 to 1000. That means 0 will be considered as lower limit and 1000 will be considered as upper limit for the hash function. Okay, now this consistent hashing had ring. Okay, this consistent hashing had a ring. 0, that means lower limit will be placed here, upper limit will be placed here. That means 0 will be placed here, 1000 will be placed here. Okay, and we have how many number of nodes we have? We have 3 nodes. We can add any number of nodes, but in the example we are considering 3 nodes. Okay, each node has an IPs, different IPs. Okay, different IPs. For example, node 1, okay, it has IP1, okay, it has some IP value, okay, IP address. Node 2, it consists of an IP address IP2. Node 3, it consists of an IP address as IP3. Okay, first this IP address will gone through the hash function. Okay, hash function which has a lower limit and upper limit. Its lower limit is 0 and upper limit is 1000. Okay, 1000. For example, after this hash function, the output will becomes as 300. Okay, again IP2 will goes through the hash function. Okay, it gives an value as 600. Okay, example. Again IP3 will be gone through the hash function, which gives an value 900. Okay, hash function as a 900. These, based upon the hash values, these nodes will be distributed in the ring. Okay, let's see for 300, it is the 300, right? The node 1 will be placed here. Okay, again for 600, node 2 will be placed in the ring. Okay, again for the 900, node 3 will be placed here. This is a 900. Okay, the first step in the consistent hashing is we take the hash function so that it consists of an lower limit and the upper limit. The output of an hash function always lies between this lower limit and the upper limit. That is the hash function nature. First we need to hash the node's IP address and get the hash values, and those nodes will be placed in the ring. Okay, now how the messages will be distributed here. Messages distribution. Okay, messages distribution. Already we had the ring. Okay, and we have placed the nodes. We have placed the nodes at hash function 300, hash function 600, and hash function 900. Now how the messages will be distributed? Again, message IDs, okay, will gone through the similar hash function, same hash function, which consists of a lower limit and upper limit as 0 and 1000. Again, it generate the hash ID. Okay, it generate an hash ID. Nodes hash IDs are, this is 300, this is 600, this is 900. We have lower limit as 0 and upper limit as 1000, right? For example, messages which are, okay, which consists of an hash IDs between 0 to 300, sorry, which consists of an hash IDs between 900 to 300, okay, which consists of an 9 hash IDs between 900 to 300 will comes to the node 1. Okay, will distributes to the node 1. hash IDs, okay, hash IDs which are present between 300 to 600, okay, 300 to 600 will be placed and distributed to node 2, and hash IDs between 600 to 900 will be placed to the node 3. This is how the consistent hashing will works. Okay, hash IDs between the 900 to 300 will be placed under node 1, and 300 to 600 under placed under node 2, and 600 to 900 placed under node 3. It goes in the clockwise direction. It goes under clockwise direction. Okay, the messages were distributed under the clockwise direction. What is the advantage of it? Consistent hashing advantage. Earlier approach, we have the disadvantage, like if any node will be down or any node will be up, it has a problems, right? But in the consistent hashing, we doesn't have such problems. That is the advantage of it. Let's see how the advantage with consistent hashing. For example, this is the ring. Okay, this is a ring. Already we discussed that node placed at 300, node is placed at 600, and node is placed at 900. Okay, node is placed at 900. Now at 300, at 600, and the 900, right? Messages between 900 to 300 will goes to this node, and 300 to 600 will goes to this node, and 600 to 900 will goes to this node. Okay, this is node 1, this is node 2, and this is node 3. Now what happened here? For example, node 2 is dropped. Okay, we have an issue with the node 2. Now how many nodes in the ring? We have only the 2 nodes. Okay, now we have only the 2 nodes. That is node 1 and node 3. This is node 1 and this is node 3. Okay, at node 1, what is the hash ID? It is the 300. At node 3, hash ID is 900. Now what happened here? Between the hash IDs between 900 to 300 will goes to the node 1, and between the 300 to the 900 will goes to the node 3. Okay, goes to the node 3. Let's see here. When the node 2 will be the dropped, the messages which are present in the node 2 will distribute it to the node 3. Okay, when the node 2 is down, automatically the messages which are present in the node 2 will distribute it to the node 3. Okay, for example, let's see. For example, message ID 6 will be there. Okay, message ID 6 will be there. The message ID 6 will be placed in the some hash function like 500. Okay, hash function of the message ID. Message 6 is goes through the hash function. The output of an hash function is a 500. So because of an hash ID is 500, earlier it is placed in the node 2. Okay, this message 6 will be distributed to the node 2. When the node 2 gets down, Okay, when the nodes 2 get down, what will be happen? All these messages will be placed under node 3. All these messages will be distributed to the node 3. Again, if you retrieve the message 6 after the node 2 is down, what happened? Again, it goes through the hash function and it gives an hash ID of 500. Okay, this 500 present between the value of 300 to the 900. That means, for example, 500 will be placed here, then automatically it will be pointed to the node 3. Okay, when the node 2 is dropped, all the node 2 messages will be distributed to the node 3, right? So when the 500 will be comes, even after the node 2 is dropped, automatically it will be pointed to the node 3. That is an advantage of an consistent hashing. When the nodes will be increased or decreased, okay, there is no impact in retrieving the messages. This is an advantage of the consistent hashing than the traditional hashing. Okay, but there are disadvantages too. What are the disadvantages of an disadvantages of consistent hashing? Okay, every approach has its own problems. In the similar way, there are the disadvantages of an consistent hashing. Let's discuss about the disadvantages of an consistent hashing. Let's take the ring. Okay, and nodes will be distributed as an earlier example at 300, at 600, at 900 in the ring. Okay, so 900 to 300 will goes to the 300 node, and 300 to 600 hash IDs messages will goes to the 600 node, and 600 to 900 will goes to the 900 node. Okay, the lower limit will be the 0 and upper limit will be always 1000, right? Always under 1000. Okay, let's see here. Let's see what is a disadvantage of this consistent hashing approach. If we have 5000 messages we need to distribute, okay, this 5000 messages, individual message is sent through the hash function, right, which has lower limit and upper limit, and we get an hash IDs. Based on hash IDs, the messages will be distributed to the nodes. Okay, there is an huge chances, right? There is a huge chances 3000 messages distributed to 600 node, and another 2000 messages will be distributed to node 1. Okay, so there is a chance, right? All the 3000 messages of an hash ID is between the 300 to 600. What happened? All these 3000 messages will be distributed to the node 2. This is node 2, right? Another 2000 messages, for example, will be fall under this 900 to 300 hash functions. Most these will be distributed to the node 1. Okay, and again node 3 will be empty. There is a chance, right? We can't control the distribution of messages, equal distribution of messages between the nodes here. Okay, hash function has only the control that the message ID should be there between the lower limit and the upper limit. That is only the control we have. We can't control the equal distribution of messages between the nodes. That is the one of the disadvantage of inconsistent hashing. Okay, first disadvantage is we can't control the equal distribution of messages across nodes. Okay, we can't control that. Second drawback. Let's see the second drawback of consistent hashing. We take the ring. Okay, we have 3 nodes, right? Okay, there is a chances that every node has an individual IP, right? For example, it consists of an IP1 and node 2 consists of an IP2 and node 3 consists of an IP3. Okay, now the problem here is this node 1, node 2, node 3 is there is a chances that there is no guarantee that these nodes will be placed at equal hash nodes, right? If you hash this IP1, there is a chances that it gets a value of 100. Okay, if there is an IP2, there is a chance that it gives a value of 200. There is a chances that this IP will gives that 900. If the values are like that, what will happen? Here it is 100. Okay, again this will becomes as 200. Okay, again it will becomes as 900 here. Okay, 900 here, or 900 here. Okay, this is of 1000 is an upper limit, 0 as a lower limit. Okay, this is 900. Now what happened here? If the nodes are distributed in this way, the most probably there is a no chances, there are very less keys will be distributed to the 200 node. Okay, then there is a chances that less keys will be distributed to the 900 to this node as well. More number of keys will be falls under this node 3. Okay, so more number of keys will be falls under node 3. This is a drawback. Okay, that means the distribution of nodes we can't control. At the same time, equal distribution of messages also we can't control. That is the drawbacks of an consistent hashing. Okay, to solve this problem, Amazon, okay, to solve these problems in consistent hashing, Amazon comes with solution. Okay, that is dummy nodes. that is placing dummy nodes in the ring. Okay, this is implemented in Amazon DynamoDB. Okay, to solve these problems in the consistent hashing, Amazon comes with the solution called placing dummy nodes in the ring in the Amazon DynamoDB. Okay, before discuss about how the Amazon solved the problem with the dummy nodes in the consistent hashing, let's see what happened if the node will be removed or node will be added. Okay, first case, node removed. Okay, the first case is node removed. We have the ring. Okay, we have nodes in place. For example, at 300, at 600, at 900. Okay, at 300 the node 1, at 600 node 2, at 900 node 3. Okay, so upper limit has 1000, lower limit has 0. Okay, this 900 to 1000 and 0 to 300 will comes into 300. 300 to 600 will comes to this 600 node. 600 to 900 keys on 900. Right? Very clear in this. For example, this node is dropped. What happened here? Okay, this 300 to 600 keys will be goes to the 900 hash node, that is node 3. Clear? Then when the node will be removed, all these keys will be goes to the 900 node. Okay, for example, node will be added. Okay, node will be added here. This is 500. Okay, this is 500. That means now what will be happen when the node will be added? Whatever the keys present in the 900, okay, keys present in 900 node, that means 900 hash node, node 3 will be redistributed, because redistributed is again gone through the hash function. Okay, to avoid the confusion, it is the node 1, again node 2 will be added. Okay, this is node 3. Node 3 keys will be again gone through the hash function, so that keys between this 300 to 500, okay, keys between this 300 to 500 will be goes to the node 2, and again this 500 to 900 goes to the node 3. Okay, that means if the node will be added between them, the forwarded node keys will be redistributed, again gone through the hash function, so that the keys between the 300 to 500 will be distributed to the node 2, and the keys between this 500 to the 900 will be distributed to the node 3. This is how the operations will be performed in the consistent hashing technique. Okay, when the node will be added, when the node will be removed, right? But there are the two disadvantages, because the distribution of an messages or distribution of a nodes we can't control. Okay, to solve the problem, Amazon introduced the dummy nodes concept in the ring. Let's see what is that concept is. Dummy nodes in the consistent hashing ring. Okay, consistent hashing ring. This is what Amazon DynamoDB is doing, consistent hashing. Now what is a dummy nodes here? We have 3 nodes, right? Node 1, node 2 and node 3, which is very clear. Okay, node 1, node 2 and node 3. They are decided that node 2, every node should introduce equal number of dummy nodes. Okay, our limits are 0 and the 1000. Okay, 0 is a lower limit, 1000 is a upper limit. This is an example. Okay, this is an example. Now let's decide that every node should have 3 dummy nodes. Okay, that means node 1 have 3 dummy nodes, node 2 have 3 dummy nodes, and node 3 have 3 dummy nodes. That means we have 9 nodes in the ring. Okay, there are 9 nodes in the ring instead of 3 nodes. Okay, there are 9 nodes in the ring instead of 3 nodes. Now what happened here? It solves the problem, but all these 3 dummy nodes will be mapped to the node 1 only. These 3 dummy nodes will be mapped to node 2. These 3 dummy nodes will be mapped to node 3. Now let's see how these dummy nodes solve the problem in the circular ring. This is a ring. Okay, for example, this is a dummy node of node 1. Okay, it consists of 3 dummy nodes. Okay, there is a chances that it is gone through the hash function. For example, it has a 0 hash function. Okay, it is an 100 hash function, it is a 200 hash function. Okay, again node 2 has an dummy nodes, 3 dummy nodes. It has 300, it is hash function that 400, again it has an hash function that 500. Okay, again node 3 has 3 dummy nodes. Okay, again it will be hashed at 600, it will be hashed at 700, for example it will be hashed at 800. Okay, but the storage will be the same. Storage will be the same. Okay, but the storage will be, these things will be mapped to the node 1, this mapped to node 2, these will be mapped to the node 3. Okay, node to the map 3. When we introduced the dummy nodes into the hash ring, more number of dummy nodes, then automatically the range will be approximately similar, right? Only here there is a difference is 200. Okay, remaining all the cases the difference will be the 100. Okay, in the remaining cases it solves a problem as 100. In this way Amazon DynamoDB solves the problem of equal distribution of nodes. Okay, equal distribution of nodes problem will be solved through the dummy nodes by the Amazon. Okay, clear? Again there is an issue. Okay, if there is an 4000 messages, this approach has also the problem. If there is a 4000 messages, for example, all the out of 4000 messages, there is a chances that 3000 messages will be reside here and 500 messages will be reside here and another 500 will be messages will be reside here. There is a chances. Still the distribution of messages problem will be exist. This problem will be solved by the Google. Okay, distribution of messages problem still exists with dummy nodes approach. Okay, this problem is solved by the Google. Google solved this problem. How the Google solved the problem? Google come up with an limits of messages for each node. Limit is equal to n into average messages per node. This is the maximum limit for a node. Okay, n is, it is depends upon your scale. For example, n is 2 times of n average messages per node. That is the max limit of messages per each node. Okay, that means if this node, while the distributing the messages, this nodes reaches the capacity, automatically that message will be forwarded to the next node to store. Okay, so the mixture of this limiting approach plus dummy nodes approach will solve the both these two problems of consistent hashing. Okay, this is how Amazon and Google solved these problems. Now the consistent hashing is completely working without any kind of effects. Okay, all these approaches, original consistent hashing approach, in this Amazon Dynamo approach and Google solving the approach. All these three approaches, I already written the code. The codes will be attached in the description. You can check the links in the description, all these three approaches with codes. Okay, I hope you people had a clear-cut understand about what is meant by the consistent hashing, what are the problems with the traditional hashing, and what are the problems with a regular consistent hashing, how the Amazon and Google solved these problems. Okay, now in the real time, when we will decide where to use consistent hashing. This is also very much important, right? Okay, distribution of messages. Always should use consistent hashing. Big question mark. Distribution of messages, should we use consistent hashing always? Answer is no. Okay, take the use case. We have rules. Okay, we need to execute these rules in 3 different servers: node 1, node 2 and node 3. For example, we have 100 rules. Okay, these 100 rules will be executed in 3 different servers. Okay, 3 different servers. That means node 1 will be execute 30, node 2 will be execute 30, node 3 will be executed as 40, or whatever it may be. Node 1 will be executed as 25 and node 2 will be executed as 55 and node 3 will be executed as 30, whatever it in the way. Okay, equal distribution doesn't matter here. Okay, but we need to execute one rule in one node itself. Whether it in the equal distribution, it is absolutely fine. Okay, so that the server capacities didn't get breached, right? Okay, if in 100 rules will be executed in the one node, then it will become always a problem in the server capacities, right? Equal distribution, in this case, equal distribution is a better choice. Equal distribution is better choice. Okay, in this case, the consistent hashing is really required here. The answer is no, because generally in this case, what the people take the approach is Kafka. Generally in the production, okay, we have 1000 rules or 1 lakh rules or 2 lakhs rules. For example, we have 1000 rules. Okay, these 1000 rules will be distributed to the Kafka, and 3 nodes will place under similar consumer group. Okay, you don't have worry about, because you doesn't have an idea about the Kafka and what is a consumer group is. Just listen. In the further, I will make videos on the Kafka also, so that you can get a clear-cut idea. Okay, just listen what is happening here. Okay, similar consumer group. If we place the 3 nodes in the similar consumer group, if you place 1,000 rules in one Kafka topic, automatically whatever the messages we placed in the Kafka topic, that will be distributed similarly, equally between the nodes which are present under one consumer group, right? So whatever the messages we placed in the Kafka topic, it is similarly distributed to the nodes under one consumer group. That is a property of the Kafka, right? For example, if you place the 2 consumer groups under one topic, then the data will be one copy of the data will be goes to the one consumer group, and another copy of the data will goes to the another consumer group. Okay, if you place the data in the topic here, if we place all the 3 nodes in the one consumer group, whatever the data which we present in the Kafka topic, it will be equally distributed, right? So the 1,000 rules we placed in the Kafka topic, and there are 3 nodes will be available in the similar in the one consumer group, then automatically equally distributed, and the rules are executed in the nodes. Okay, there are another use case. The rules will be executed at every day at one particular time. Generally what the people will do, the people will place an schedule job here, schedule job. The schedule job will place the messages in the Kafka topic, then the messages will be distributed to the nodes. Okay, in what case the consistent hashing is mandatory? That is really important. In what case consistent hashing is mandatory? Mandatory in what case? Where there is a use case, you need to retrieve the message. Okay, in this Kafka use case, just we need to execute the rules. We don't need to retrieve the rule once it is distributed, right? In those cases, this approach will be perfectly fine. But where there is a need of a retrieval the messages, in that case the consistent hashing is the only solution we have. Okay, I hope you had a clear-cut idea about what is meant by the consistent hashing, how it solves the problem of a traditional hashing, and what are the problems we faced through the consistent hashing, how the Amazon engineers and Google engineers solved the problems with their approaches, and in what places the consistent hashing is really required. All these topics we clearly discussed in this video. It is really important for the interview, because the consistent hashing is an heart for the peer-to-peer architecture. While designing the peer-to-peer architecture, the consistent hashing is an heart. Okay, when we are designing in any kind of an architecture, peer-to-peer architecture, the consistent hashing is very much important. Okay, I hope, maybe it is a long video, I hope you learned all the concepts in detail. Okay, thank you. If you really like this video, please share, subscribe and comment under this video. Okay, thank you.